It's the enthalpy change required to remove 1 mole of electrons from 1 mole of gaseous atoms of the element to form 1 mole of gaseous 1+ ions. Now the equation for magnesium will be Mg gaseous goes to form Mg plus gaseous plus E minus. The second ionization energy is the enthalpy change required to remove 1 mole of electrons from 1 mole of gaseous 1+ ions of the element to form 1 mole of gaseous 2+ ions. Now the equation for the magnesium will be Mg plus gaseous goes to Mg2 plus gaseous plus an electron. The enthalpy change required to remove 1 mole of electrons from 1 mole of gaseous 2+ ions of the element to form 1 mole of gaseous 3+ ions. The equation, Mg2 plus gaseous, goes to form Mg3 plus gaseous plus E minus. It increases. Now we're going to talk about the distance of the outer shell electron from the nucleus. We're going to talk about the energy level that the outer shell electron occupies. We're going to talk about the shielding between the nucleus and the outer shell electron. And we're going to talk about the nuclear charge. Now let's go back to shielding and make sure that we understand what shielding is. Now this is my take on it. Imagine this is a classroom at school. The teacher's desk is at the front. The students are going to sit at desks A, B and C. One of the students is going to write X was ear on the table. Now, for a student to do that, they would sit at desk C. There they are. They're the blue X. Now, why would a student sit at desk C if it was going to write its name on the table? Well, the reason being that it's further away. Also because row A are shielding the blue X from the teacher and row B are shielding blue X from the teacher. So X is being shielded by both those rows of students. Now how does this apply to an atom? Well, the teacher is the nucleus and each of these rows are principal quantum number 1, principal quantum number 2 and principal quantum number 3. So the electron is removed from the third energy level. Shielding across a period is approximately constant. Nuclear charge is increasing, as is indicated by the 11p+, 12p+, 13p+, etc. all the way up to 18p+. So the electrostatic attraction increases, so more energy is required to remove the electron. And as a result of that, the distance of the outer shell electron from the nucleus decreases, so it's pulled closer to the nucleus. It decreases. Now, even though the nuclear charge is increasing going down a group, the electrons are being removed from higher energy levels, which are further from the nucleus. Shielding increases. So the increased distance, energy level and shielding outweighs the increasing nuclear charge, so there is a weaker electrostatic attraction, so less energy is required to remove the outer shell electron.